Hello students, welcome once again. You're watching Azmal Super 40 online classes. Okay, so we have seen in the last class there was a big response from you all. Hi sir, nice sir, we have loved your lectures. Okay, very good, we are highly delighted. So I'm again coming with the second lectures on electrostatics. Okay, so in the last class we have discussed about the charges, the properties of charges. Okay, now in today's class we'll be discussing about Coulomb's law and superposition principle. Okay, so instead of having much talk, okay, let us go and start it. Okay, good. Coulomb's law. So in the last class we have learned the charges, they interact with each other. Okay, charges, they interact with each other. Like charges, they repel, and unlike charges, they attract. Okay, so charge is that property by virtue of which two bodies can attract also and two bodies can repel also. Clear? Okay, so if that is the case, then how much force one charge is going to exert on the other? Okay, Coulomb has shown it. What Coulomb has said, if we consider 2-point charges, what charges? 2-point charges separated by a distance r, then these two charges will exert a force on each other, and the magnitude of that force and the magnitude of that particular force will be directly proportional to the product of the charges and inversely proportional to the square of the separation between them. So when you make it equal, so force becomes is equal to a constant of proportionality Q1 Q2 by R square, as simple as it is. Okay, this is known to us, we know it very well. Okay, there's not a big relation. Okay, right. So here K is a constant whose value will become 1 by 4 pi epsilon naught in vacuum. Clear? Epsilon naught, permittivity of free space. What is permittivity? Okay, permittivity क्या है? अच्छा, okay, fine, I am leaving it for you. You will tell me what is permittivity. 1 by 4 pi epsilon naught, and that is equal to 9 into 10 to the power 9. What is the unit? Newton meter square by Coulomb square. Newton meter square by Coulomb square. This is the value of K in vacuum. 1 by 4 pi epsilon naught. Epsilon naught is permittivity. Okay, 9 into 10 to the power 9 Newton meter square by Coulomb square. This is Coulomb's law. Okay, so according to Coulomb's law, the force between 2 point charges, okay, we are considering point charges or point like charges, we can call. Point like charges means a spherical distribution of charge. Spherical distribution means having 3-dimensional symmetry. I mean, charge distribution should be same along x, y, and z. Along all the 3 axes it should be same. Okay, point like a sphere. Sphere is a can be considered to be a point like body. So a spherical distribution of charge also we can call it like point like. So the Q1 and Q2, so the force between 2 point charges, we can see from here will depend on 3 things: product of the charges, separation between the charges, and the medium, okay, on which we are putting the charges. So this is where again it differs from Newton's law of gravitation. The expression of this force is exactly like Newton's law of gravitation. What was Newton's law of gravitation? Force was equal to G m1 m2 by r square. Okay, G m1 m2 by r square. So gravitational force between 2 point masses does not depend on the medium, but electrostatic force will depend on the medium. Okay, how it will depend on the medium? There is something called polarizations. We'll be learning it in due course of time. Okay, so three things: it depends on the product of the charges, it depends on the separation between the charges, and number three is what? It depends on the medium. Clear? Depends on the medium. Okay, let me show you. Let me show you. 2 point charges Q1 and Q2 separated by distance r in vacuum or air. Clear? Again, same two charges Q1 and Q2 at the same separation but placed in a medium. Okay, the force between these two charges in vacuum is suppose F naught, and the force between these two charges in medium is suppose Fm. Okay, it will get reduced. Force in the medium will become smaller than a force in vacuum. Okay, in medium, because of polarization, one more electric field will get developed. One more electric field will get developed in a direction opposite to the applied electric field. Okay, in vacuum there is nothing, only one external field. But in vacuum, what will happen? There will be two field. Sorry, in medium, what will happen? There will be two field. One is external field, one is another field that will develop within. Okay, because of polarization of the medium molecules. Okay, so the induced electric field that will get developed, which will become opposite to the applied electric field. So net electric field will become, if it is in vacuum, it was F naught. So in medium, it will become Fm will become F naught minus another electric field will be there, induced electric field, because of which another force will be there in the opposite directions. Okay, so about this we'll be talking in detail in polarization. Okay, so if the force between the two charges in the medium, if it is F naught, then we'll be calling it as what? How much is F? 1 by 4 pi epsilon naught, permittivity of vacuum, Q1 Q2 by R square. And Fm will become how much? 1 by 4 pi epsilon m, will be writing permittivity of that particular medium. Okay, into Q1 Q2 by R square, Q1 Q2 by R square. Therefore, the ratio of these two forces, how much it will become? The ratio of the forces between the two charges in medium by vacuum. If we divide it, how much will get? This ratio will become how much? If you say this is F naught, so let me take it like this: force between the two charges in vacuum by force between two charges in medium. So how much it will become? F naught epsilon naught Fm epsilon m. This particular ratio of the force between the two charges in medium by the force between the two charges in force between the two charges in medium by force between the two charge. Okay, I'm getting mixed up out here. This is vacuum and this is medium. F naught, it is the force between the two charges in vacuum, and Fm, it is the force between the two charges in medium. Their ratio will be defined as K. That is another K. Okay, here also we have used the K, but this particular K, let me call stylish K. Okay, this particular K will be called as dielectric constant. What? Dielectric constant. Okay, so that means dielectric constant K is what? Epsilon m by epsilon naught. This is also represented by epsilon r. This epsilon r we call relative permittivity. That means permittivity of medium by permittivity of vacuum. This is called relative permittivity. This is also called as dielectric constant. Okay, so we have seen the ratio of the forces. So how we will define dielectric constant? So if we go from vacuum to medium, if the medium dielectric constant is, 2, suppose K, dielectric constant of this medium is 2, then how much will get? F naught by Fm is how much? K or epsilon r. How much will become? That is 2. That means how much is Fm? Fm will become F naught divided by 2. That means dielectric constant is that factor by which the magnitude of force between the charges will reduce when you take the system of charges in the medium. Okay, तो इस मीडियम का अगर डायलेक्ट्रिक कांस्टेंट 2 है, अगर यहाँ पर वैक्यूम में फोर्स was 4 न्यूटन, in the medium for the same separation, for the same charges, the force will become half of that, will reduce by 2. That means it will become 2 Newton. If it is 4 Newton in vacuum, then in medium it will become 2 Newton. So this is the point you need to understand. Okay. So here we have learned about dielectric constant. So we have seen the charge force between the charges. Okay, Coulomb's force. It depends on the separation between the charges, product of their magnitude and a medium. Okay, another point. Suppose one charge is Q1 and another charge is Q2. The force between them is F. Force between them is F. So if we put a medium out here, Q1, Q2, we are putting a medium here now. We are putting a medium having dielectric constant 2. What was the force between them here? F. Here the force between the two charges for the same separation, how much will become? F by 2. Clear? Okay, this is the effect of dielectric constant. Note it. Now, another point. These are the two charges. Force between these two charges is F. I am bringing a third charge, Q3. What will happen to the force between the two charges now? Initially, the force between Q1 and Q2 is F. Now, what will happen to the force between Q1 and Q2? It will become more than F or less than F in the presence of a third charge. Okay, I can put one more charge, Q4. What will happen? The force between Q1 and Q2 is independent of the other charges present in their vicinity. In a neighborhood, bring any number of charges. Force between Q1 and Q2 will remain the same, because force between Q1 and Q2, what we will see? We will see the medium. We will see the medium. Okay, so here medium is vacuum, no medium, or air, right? We will see second thing is what? Product between the two charges, Q1 and Q2. Then what we'll see? We'll see the separation between them. Clear? So the force between the two charges is independent of the other charges present in the neighborhood. Okay, if the question is asked like this, what is the net force on Q2 here? So here net force on Q2 means there is only one force. Who will exert? Q1 will exert. Here if they ask you, in this particular situation, if they ask you, what is the net force on Q2? So we'll say net force on Q2 is nothing but the sum of the forces by 1, by 4, by 3. Okay, that is a different issue. But as far as it is concerned, Coulomb's force between Q1 and Q2 in the first situation, between Q1 and Q2 in the second situation is going to be the same. So this is another important point you need to understand. Right? Force between the two charges is independent of the other charges present in their vicinity. Okay? Now, if we talk about a charge Q0, and in a neighborhood many charges are present, Q1 is there, Q2 is there, Q3 is there, like this to tell n number of charges, Qn. What will be the net force experienced by Q0? Okay, that is called superposition principle. superposition principle. Superposition principle. So net force on Q naught will become how much? One force will be by Q1, another force will be by Q2, the third force will be by Q3, like this. Total n charges are there. How many forces will be there total? N number of forces. N number of forces. Then what will be the net force? Net force will be the vector sum of F1 plus F2 plus F3 plus plus Fn bar. This will be the net force, or 1, 2, 3, like this. This is called superposition principle. Clear? For example, let me show you a quick example. There's a charge Q, there's a charge Q, there's a charge Q. What is the net force on Q? Suppose this all the separation are R. Let me call this is an equilateral triangle. What is the net force on the charge at A? Suppose this is point A, this is point B, this is point C. The net charge at the vertex A, one force will be by B and the other force will be by C. Okay, so since this is an equilateral triangle, angle between them will become how much? 60 degree. So what will be the force net force on A? Net force on A will become force by B plus force by C. What sum? Vector sum. That means you have to consider the angle between the two forces. Angle between the two forces. How much will become? Let me calculate it. What is the magnitude of force by B? Force by B, between force exerted by B on A. What is the force? K, Q into Q, Q square divided by separation, R square. What is the force by B? Force by C? Force by C will also have the same magnitude. Force by C will have the same magnitude. FC, K Q square by R square. Okay, let me call these two forces is equal to F. Say, then what will be the net force? Force net will become square root of FB square plus FC square. But FB, FC, both I can call it to be equal to F and F, plus twice FB into FC. Okay, cos of the angle between them, cos how much? 60 degree. Cos 60 is equal to half. Half and 2 will get cancelled out. F square plus F square plus F square, that is equal to 3F square root 3 F. Root 3 F. This is going to be the net force between the charges. Clear? So we have used the formula vector product. Okay, vector sum square root of A square, R is equal to A square plus B square twice AB cos theta. This is the formula we have used. So on this particular, at this particular vertex, the net force, there will be two forces, one by B and other by C. Angle between the forces is 60 degree. So net force will be according to superposition principle, force by B plus force by C. So like something like R bar is equal to A bar plus B bar. Okay, so therefore the magnitude of FC and magnitude of FB are going to be same because magnitudes are same, separations are same. Okay, we have called these two forces to be equal to F, then FC square, FB square, okay, plus twice FC, FB into cosine of the angle between them. This is, okay, root 3 F. This is how we can understand superposition principle. Acha. Before proceeding further, let me show you the Coulomb's force in vector form. That is also important to understand. Coulomb's force in vector form. Coulomb's force in vector form. First of all, if this is Q1, this is Q2, I have directly said force between them will become 1 by 4 pi epsilon naught Q1 Q2 by R square. I have not talked about the direction so far. Okay, so Q1 and Q2, they will exert a force on each other. Now they are appears to be positive. In ideal situation, we'll consider positive charges, right? So there will be repulsion between them. Q1 will exert a force on Q2 away from it. This is the force exerted by 1 on 2 will repel. Similarly, 2 will exert the same force on 1 in the opposite direction. So you can call this is something like a pair of action and reaction forces. You can call it as action and reaction forces. What is this? This is the force experienced by 2, okay, due to 1. And what you can call it as? Force experienced by 1 due to 2. I'll use the symbol like that. Force on 2 by 1. And this is what? Force on 1 by 2. So this force is by whom? By Q2. And this force is by whom? By Q1. So if you write force on 2 by 1, okay, so you'll have to use what? This is the magnitude. What is the direction? Direction is from 1 to 2. Direction is from 1 to 2. If I call R1 to cap along this direction, what is that? This is direction, unit vector. Sir, how to work on that? Acha, let me come to it. Let us talk about position vector. Position vector, hello, position vector, remember. Suppose the charge Q1 is here. And let me make the diagram little bigger. Okay, so here you'll be able to understand it better. So this is the charge Q1, and let me consider this is the charge Q2. Okay, and this is the coordinate I'm considering on the XY plane. Okay, that's okay, fine. Let me consider this is x-axis or whatever, this is y-axis, whatever it is. Z-axis I'm not showing anyway. Let me consider in a space also, no issues. From here to here, I'll call this vector to be R1. Q1 is located at a distance. Q1 is located at a distance R1. This is R1 bar. This is R1 bar. And what is the direction of R1? From origin to the point. This is R1. This is R2. Position vector of the second charge. Okay. This one I'll call R2 bar. Position vector is away from the origin towards the point. Okay. Now we have to find what is our R12 cap. The force, this is the direction of force exerted by, this is the direction of force, sorry, let me make it 2, 1. Okay. This is the direction of force exerted by 1 on 2. Direction of force experienced by 2 due to 1. In which direction 1 will exert a force on 2? In which direction? In this direction. I'll call this is F on 2 by 1. I'm going as slow as possible. You try to follow. Clear? And this will be the direction of what? Force on 1 by 2. Force on 1 by 2. Force on 2 by 1. Okay. So if I call this particular point to be A and this particular point to be B and this particular point, let me call it as O, then we have got a triangle OAB. Okay. Let me draw the triangle first. OAB. I'll use now triangle's law of vector addition. Let me call this particular point as A, this particular point is B, and this is O. Okay. This is R1 bar. This is R2 bar. Okay. Then the third vector I can call it as AB bar, or I can call it as BA bar. BA bar. If I call BA bar, it is in the direction of F12. Or if I call it as AB bar, that's going from A to B, AB bar, it is in the direction of F21 bar. Is it clear? So now question is what we want here. I want the direction of the force experienced by 2 because of 1, and for that I have given a direction 2 1 cap, force 2 1 cap. This is a symbolic representation. Okay, so instead of 2 1 cap, I can call it what? Force on 2 by 1. In which direction? This direction. This is the direction of AB. Listen carefully. Listen carefully. This is the direction of what? AB. This is the force on 2 by 1. This is the direction of what? This is the direction of AB. AB. Clear? So direction of 2 1, F21 is in the direction of AB. I call AB cap, unit vector in the direction of AB. Okay? See here, I'll just rub it off. What is AB from this triangle? Let me rub it off also. What is AB bar? This is the direction of AB bar. This is the direction of what? AB bar. What is AB bar? If I look at this particular triangle, there are two vectors in same order, and this is the third vector in opposite order. So if you remember, okay, this to sum of these two vectors will become equal to the vector which is in opposite order. These are two in same order. That means R1 bar plus AB bar, R1 bar plus AB bar is equal to R2 bar. So AB bar is basically nothing but R2 bar minus R1 bar. Okay, so a unit vector, that is AB cap. How much will get AB cap? A unit vector is nothing but the vector divided by its magnitude. Let me call the magnitude is AB. Then how this will look like? How this will look like? R2 bar minus R1 bar divided by modulus of R2 bar minus R1 bar. This is AB cap. Okay, so that means in case of the unit direction, unit vector, I can put R2 bar minus R1 bar divided by R2 bar divided by magnitude of R2 bar minus R1 bar. Okay, this is the unit vector. If in case if we have to calculate, we'll get it like this. Similarly, if you have to get the expressions, force on 1 by 2, force on 1 by 2 will be in the opposite direction. Opposite direction means what? This will just get reversed. Opposite direction means what? What do you want? BA. BA in this direction you want. This is the direction of force on 1 by 2. BA. So BA from here, how much will become? In this situation, these two vectors will be in same order. R2 bar plus BA bar. And R2 bar plus BA bar, which will become equal to R1 bar. So from here, BA bar will become R1 bar minus R2 bar. So this will become 1 by 4 pi epsilon naught Q1 Q2 divided by R square unit vector along BA. Unit vector along BA is nothing but BA cap. And if you say BA cap is opposite to AB cap, okay, this is negative of BA cap. So if I have to get BA cap, I have to bring the negative to this side. So this is R2 bar minus R1 bar will become R1 bar minus R2 bar. 1 by 4 pi epsilon naught Q1 Q2 divided by R square. This one I will write it as R1 bar minus R2 bar divided by modulus of R1 bar minus R2 bar. Okay. Let me rewrite once again. Let me rewrite once again. This is Q1 and this is Q2 separated by distance R. This is F21 and this is F12. Separation is what? R. So force on 2 by 1 is K Q1 Q2 by R square. Okay, R21 means what? R2 bar minus R1 bar divided by modulus of R2 bar minus R1 bar. Okay, so this is basically nothing but magnitude of the, this is nothing but magnitude of the separation between the two charges. This is R1 bar, R2 bar. We have seen R2 bar minus R1 bar is nothing but, okay, for example in the first case we have got AB bar kitna tha? R2 bar minus R1 bar. So what is the magnitude AB? AB means the separation between the two charges. AB, A, B, separation between the two charges. Okay, R2 bar minus R1 bar. So in this particular situation, AB you have considered to be equal to R. So this one you can replace by R. So if this particular part you replace it by R, then finally what we get? R cube. So I can modify it as what? R cube. Then this will look like this. This is F21 bar. So K Q1 Q2 divided by R cube, position of the second charge minus position of the first charge. Similarly, F12 bar K Q1 Q2 divided by R cube R1 bar minus R2 bar, position of the first charge minus position of the second charge. That is the direction of F1 to this direction. Okay, this is Coulomb's law in vector form. Okay, now we have said this is Q1, this is Q2, these are point charges. So if they are not point charges, what exactly we are going to do? If they are not point charges, what we are going to do? For example, if there is a linear rod having charge Q out here, what is the total charge? Q. What is the length? L. From this particular rod at a certain distance R, there is a point charge Q. Then what will be the Coulomb's force between them? Can we apply Coulomb's law directly or not? Sir, क्या करें इसको? We'll consider the net charge to be at the center of mass. Okay, so at a distance L by 2. Can we do that? At a distance L by 2. Sorry, यहाँ से यहाँ L by 2 है, center of mass. So center of charge. And this is from here to here, this is R. Okay, this is Q. So can you do force between them will become K Q1 Q2 divided by R plus L by 2 whole square. Yeah, we cannot do this. This will become wrong. Okay, this is not correct. So what is the correct method? Okay, I'll show you. So this particular method we have to remember well, because that will not be applicable here only, that will become applicable in gravitation also, that will be applicable in we'll be needing in magnetic effect of current, that is in magnetism also we'll be needing that, right? In different parts of physics we'll be needing that particular technique. So for that what we'll do, Coulomb force is between two point charges, So this particular charge is point. Let me consider a very small portion here. Let me call a portion is dx, very small portion. Okay, so that it will appear to be like a point. I'll call this is an elementary portion, okay, which contains a small charge dq, and from this particular charge this element considered is supposed at a distance x. What is the distance from here to here? X. Now this is a very small element, so I can consider it to be like a point. What is the charge on this element? Q. How much is Q? I'll use unitary method. What method? Hello, what method? Unitary method. What is unitary method? The total length is L. Total length is L. This L length contains total how much charge? Q charge. And in this particular situation, we'll assume the charge to be uniformly distributed. That means uniform linear charge density. Linear charge density means charge per unit length. Okay, so the length L has got a charge Q. Therefore, a length dx will have a charge dq. dq is what? Q by L into dx. So we have got a point charge out here. How much is the point charge? dq. So the force between these two charges will become how much? Let me call df. df is what? K q1 q2 by distance square. K q1 q2 by distance square. So now let us replace dq by this particular part. How much it become? K q capital Q dx by L, okay, divided by x square. This is the force exerted by this element on this particular charge Q. In which direction? If I call positive, this is positive, so this will exert a force on it in this direction. This is the magnetic direction of df. Okay, so if I consider another element, this will also exert the same force. This will also exert force, very small force in this direction. If I consider another element, this will also exert a force in the same direction. If I consider an element here, this will also exert a force in the same direction. That means I have to consider all possible elements like the elements I have considered. So all these elements will exert a force on Q in the same direction. That means net force will be sum of all the forces exerted by all possible elements on this particular rod. Okay, so that is why net force will become what? Sum of all these forces, and this summation will become what? Integration. Because I cannot call how many elements are there, 1, 2, 3, I cannot count. So many elements are there. So this kind of addition will be done by integrations. So that is why this will become K capital Q small q by L integration dx by x square. What is x? Distance of these elements from the point charge. Distance of these elements from the point charge. Where is the nearest element? This is the nearest element. At what distance it is? It is at a distance r. So where is the farthest element? The farthest element is here. This farthest element is at what distance? At a distance of r plus L. So the possible values of x. So smallest value of x is r, and the largest value of x means the distance of the element from the charge is how much? Largest possible value of x is how much? R plus L. So here limit of integration will go from r to r plus L. So how much will get here? So f is equal to k capital Q small q by L integration 1 by x square is nothing but minus 1 by x, r to r plus L. So the force F will become K Q capital Q by L. Minus is there, so I'll put the lower limit first, then I'll put the upper limit. That means removing the minus, I have rotated the limits. That can be done. So this is 1 by r minus 1 by r plus L. So F will become K Q Q by L. If we take LCM, r plus L minus r. Okay, in the first line r and r will get cancelled. In the next line L and L will get cancelled. So how much will be left out with? K capital Q small q by L. How much will left out with? Oh, L will get cancelled in the next line, right? R into r plus L. This is the force. Okay, so this is how we can calculate. Understood? Yeah. Okay, let me show you another problem. Using superposition principle. Suppose there are 4 charges placed at the 4 corners of an equilateral of a square of side r. Suppose all separations are r. Okay, let me consider identical charges q, q, this is also q, this is also q, a, b, c, d. And suppose we have to find net force at any of the vertices. Net force at any of the vertices. Let me specify. Find net force on the vertex A. On A we have to find using superposition principle. Question is how we will find out. How many forces are on A, at the vertex A? At the vertex A, one force will be by B. Okay? Repulsion. There is a force by B. There is a force by D. Okay, these two forces will be at 90 degree. Okay, and the other force is by C. Other force is by C. These are the 3 forces. Okay, we have to find out the resultant of these 3 forces. कैसे निकालोगे resultant of these 3 forces? Okay, let us first see the magnitude. Force by B. How much is that? K q square by r square. This is also going to be the magnitude of force by D. So these 2 forces are of equal magnitude. Same charges, same separation. What is the force exerted by C on A? We have to consider this particular distance. This distance is what? Root 2r, diagonal of a square. R, root 2r. So FC will become how much? K q square root 2r whole square. So k q square divided by twice r square. This is the force by C. Force by C. Okay, note it down. Force by C. Okay, now we can solve it very nicely, because this particular since this is going to be a square, this particular diagonal is going to bisect the angle 45. Okay, so that means FC is making 45 with FB, 45 with FD, 3 forces. So for that, first what we'll do, we'll find the resultant of B and D. B is along this direction and D is along these directions. Which is bigger? They are equal in magnitude. If they are equal in magnitude, if I use parallelogram law of vector addition, then the resultant will be represented by the diagonal. Resultant will be represented by diagonal. This is a resultant of B and D. I'll call FBD. Will be in which direction? Will be along the diagonal of this parallelogram. But this parallelogram here is nothing but it is going to be a square. So how much this angle is going to be? 45 degree. This angle is how much? 45 degree. That means the direction of FBD and direction of FC are going to be the same. Okay, so first of all, let me calculate what is FBD. FBD is nothing but the square root of FB square plus FD square. Okay, both are equal in magnitude. Both are equal in magnitude. So resultant will become how much? Root 2 FB or root 2 FD, whatever it is. Let me call this is equal to F. So student, this will become F. Finally, FB will become how much? Root 2 F. Okay. This one I have considered to be F. So FB, this is also F. This is also F. Root 2 F. This is what exactly finally I have got. So now see what exactly I said. FBD and FC, they are going to be along same direction. If they are going to be along same direction, this is also the direction of FBD. This is also the direction of C. So therefore, net force at the vertex A will be the sum of these 2 forces. Sum of these 2 forces means FC plus FBD. How much is FC? This is FC. K q square by 2r square. K q square by 2r square. And how much is FBD? Root 2 k q square by r square. So finally, the resultant force how much we have got? F net half plus root 2, half plus root 2 k q square by r square. K q square by r square is common, half plus root 2. So students, आज के लिए इतना ही काफी है. हम यहाँ से कंटिन्यू करेंगे in the next class. Okay, till then, all the best.